Sequences and series. This is another topic that instructors like to introduce into algebra courses as a prelude to those going on to higher level math courses like probability and statistics, calculus, and even some physics. The good news is they usually don't spend a lot of time on this topic, and the concepts and problems are actually pretty straightforward, so it's worth knowing. When we hear the term sequences in math, it means pretty much the same thing it does in ordinary language. In this case, an ordered or patterned arrangement of numbers. Take the example below, 0, 4, 8, 12, 16, and so on. It's easy to see that there's an ordered pattern here, and that the integers increase by a value of 4 with each number. Similarly, in the example below, we have 1 over 8, 1 over 16, 1 over 32nd, and 1 over 64th. The pattern here is 1 over 2 times some number, starting with 8 for the first term. Each item in a sequence of numbers is referred to as a term. When it comes to sequences, we have two types of sequences: finite sequences, which have a specific number of terms, and infinite sequences, which include all numbers to infinity. One common pattern of sequences you'll see in math and many other scientific fields are called factorials. For a positive number n, a factorial is defined by that number with an exclamation point following it. Let's take a look at a few examples. For 7 factorial, you basically multiply 7 times 7 minus 1, which is 6, times minus 1 again, which is 5, times 4, times 3, times 2, times 1. So basically, whatever the number is factorial, you start out with that number, and you multiply it by each subsequent term, which is 1 less than the number before it. So for 6 factorial, we have 6 times 5 times 4 times 3 times 2 times 1, and so on. 0 factorial is always equal to 1. Another type of problem you'll get is the following. You'll be given the pattern of a sequence. In this example, a sub n is equal to 2n plus 1. And they'll ask you to do something like, find the first 5 terms of the following sequence, starting with 1. To find the first term, you would take the pattern and you would fill in 1 for the value of n. In this case, it gives you 2 times 1 plus 1, which is equal to 3. And then for the next 4 examples, you keep increasing the value of n, until finally you get up to the 5th term, which would be 2 times 5 plus 1, which is equal to 11. The good thing about these problems is that on an exam or quiz, they'll almost invariably tell you which term to start with, as in the following example. They want you to find the first 5 terms of the following sequence, starting with n is equal to 0. If they don't specify for some reason, the safest bet is to always start with 0, and the reason for this has a lot to do with concepts that come from computer science and the like. Let's take a look at another couple of examples. This time, instead of dealing with sequences where only multiplication and addition are involved, let's take a look at some sequences that involve fractions and factorials. Here we're taking a look at the sequence a sub n is equal to 1 over n factorial, and we're starting with 1. Let's find the first 5 terms of that. In the first case, we have 1 over 1 factorial. Since 1 factorial is equal to 1, we have 1 over 1, or 1 for the first term. The second term would be 1 over 2 factorial, which would give us 1 over 2 times 1, which is equal to 1 over 2. I think you see where this is going, so let's take a look at the 5th term, 1 over 5 factorial. That gives us 1 over 5 times 4 times 3 times 2 times 1, or 1 over 120. Now let's look at the same problem, except that instead of starting from n equals 1, we'll start with n equals 0. So the first term would be 1 over n factorial, in this case 1 over 0 factorial. But we said that 0 factorial is equal to 1, so this leaves us with 1 over 1 is equal to 1. From there, we can increase n by 1 and keep finding the subsequent terms, which kind of looks like what we have on the left. It's just that in this case, we started with 0 instead of 1. So for example, the 5th term of this sequence would equal 1 over 4 factorial, or 1 over 4 times 3 times 2 times 1, which equals 1 over 24. So that's the 5th term in this example, whereas it was the 4th term in the example that we looked at previously, because we started numbering terms at a different spot, 0 in this case instead of 1. Let's take a break here. When we come back, we'll continue on with some additional sequences concepts.